All right, so this is where we got to yesterday. We took axis of symmetry, x equals negative b over 2a. We got 0. That automatically, every single time, will be the same thing for the x value of the vertex. We get that for free. So two birds with one stone, as they say. And then we plug that x value into the original problem for x. Everywhere there's an x, you put a 0 for that one and work it out. And that gets you the y value. That creates the vertex. And remember from yesterday, the vertex is going to be either a maximum or a minimum. Which one is this one going to be? Why is it going to be a minimum and not a maximum? A is what? It's a positive number. And if A is positive, then it's going to, when we draw this today, it's going to make that sort of shape. It's going to open up like that. So the minimum, that vertex is this point where my thumbs are coming together. Okay, this is the kind of the shape it's going to make. Where my thumbs come together, that's the vertex. And that's going to be a minimum. So we write minimum beside that, or min for shorthand for that. All right, now here's how we're going to build the rest of that graph and be able to get an accurate picture of what x squared minus 2 looks like. And this is, the addition of stuff for today. And that's where we're going to make a table of values. And the way we're going to make the table is strategic so that we get a good picture. We want a good picture of that because remember I told you yesterday about the axis of symmetry? It was like when you folded a piece of paper in half so you get it to line up. We want to make a table that will do the same thing, that'll help us get a good picture like that. So we're going to take this vertex that we found here, we're going to put it in the middle of the table. So leave yourself a couple of lines there, and I'm going to put 0, -2 right there. That's my vertex. I'm going to circle it, okay, because that's an important point. It's maybe one of, sometimes it's the most important point. Sometimes it's one of 3 very important points for a quadratic. But today it's the important point, okay? The next thing that I want to do is to be symmetric. We're looking at a graph that's going to look something like this. We want to go to the left side of that and then to the right side of that. So what's left of 0 on the number line? -1, and then left of that would be -2. So those are the x values that I want to use. What's to the right of 0? +1, +2. Okay? Now, those are x values. How do I get the y value that goes with them? Plug it into the equation. Just like we did to get the vertex, right? No different. We're just going to plug in -2 instead of 0 and work that out into x squared. So -2 into x squared. And you don't have to write those things out. You can do that in a calculator if you want to. That's fine. I'm going to write it out on here on their notes, and then that way we see where we're getting these numbers. When I plug in -2, what's -2 squared? It'd be 4 minus 2 is +2. So the y value that goes with -2 is +2. Okay. I'm going to do the same thing for -1. I'm going to plug it into the problem and work it out. -1 squared minus 2, bless you. Okay, so -1 squared would be +1 minus 2, -1. So the y value that goes with -1 is -1, which happens to be the same number. Not always going to be that way. And then I'm going to go down. I've already got 0, -2 worked out. I don't have to work it out again. I'm going to go down here and work out +1. Plug that in. That ends up being 1 minus 2 again, which is still -1. And then the last one, I'm plugging in a +2 for x and working it out. So we're just plugging in these numbers here for x and working them out to get ordered pairs. Okay. So +2 plugged in there would be 4 minus 2, which is 2. Happens to be the same numbers again. Most of the time, it's going to do that. I won't say it's all the time, but it's most of the time. what we're dealing with. So now we've got this table right here of ordered pairs. We can draw that and plot those points on a coordinate plane. We can draw a coordinate plane and plot those points. That's what I'm getting at here. That's going to build our graph. Okay, so we're going to go on a coordinate plane. So draw yourself just a small coordinate plane. Doesn't have to be real big because our x and y values aren't real big. And I'm going to take this table and I'm just going to paste it right here so we don't have to scroll back and forth to see it. These are my ordered pairs I'm graphing. I'm graphing -2, +2. That point is right here. It's that dot right there. Left 2, up 2. That's the -2, +2 point. Then I go to the ordered pair -1, -1. That would be right here. So I put a dot there. And then I'm going to the vertex 0, -2, which is right there. Then I'm plotting this point 1, -1. So that'd be over here to 1 and down to -1. That's right there. And then the last ordered pair is 2, 2. 2, 2 would be right here. Yeah, on the positive side. That's right. Then I've got a shape going there. Can we see that if I connected these with a line, it makes that parabola looking shape that I've been drawing for the last couple of days? All right. Now, there's one other thing that we want to graph on here. What else did we find yesterday? We found the vertex. We've already got the vertex plotted. The axis of symmetry. We hadn't put that on here yet, so we're going to draw it. It is this imaginary line. It's a dotted line that goes right down through the center of that one. This one's hard to see because it's right on top of the y-axis. When we get another one that kind of moves to the left or to the right, it's real easy to see there. But it's this line that if we pick this screen up and we're able to fold it, it would match up on each side. The graph, we've just got to kind of try to draw it as best we can. We've got these 5 points here that help us get that part pretty close. The rest of it, you just kind of try to match it up. We get this parabola shape and the axis of symmetry running right through the middle of it. Okay? So we're taking what we did yesterday, vertex, axis of symmetry, maximum, minimum. Can we see that that's a minimum? It's got a lowest point. The lowest y value is what? -2. The lowest y. If I ask you what the lowest y value is, then just give me the y value. If I ask you what the lowest point is, then that's the 0. That's actually the vertex there. Okay, so when we're looking at this, when we're deciding maximum, minimum, our graph should show us that. We can know it by A. If A is positive, it's a minimum. If A is negative, it's a maximum. But when we look at our graph, it should show us that we've got a lowest point here. It's a minimum. Okay, so that's what we're going to be building today. All right, let's look at another one. Example B. Let's do y equals -x squared minus 4x plus 3. Pretty simple there. And we're going to do the same thing. We're going to find the axis of symmetry, the vertex, and we're going to do a table. And then we're going to graph it on a coordinate plane. I won't draw the coordinate plane until I know what my x and y values need to be. I don't know how big to draw it. Okay? So what's the first thing that we should do? A, B, and C. You've got to know A, B, and C. What's A? -1, B, C, +3. Okay? Axis of symmetry. -b over 2a. So the opposite of b, that's what -b means. So if b is -4, then what should be on top? +4 over 2 times -1. 2 times a. It's always 2 times a on the bottom, so it's 2 times whatever a is over here from the problem. That's where the 2 times -1 comes from. Okay, so that ends up being 4 divided by -2, which is -2. So the axis of symmetry is x equals -2. That means that what part of the vertex do we have? You got the x value of the vertex. It's -2. How do you find the y value of the vertex? Plug it back into the equation, 4x. So we got negative parentheses, -2 squared minus 4 parentheses, -2 plus 3. You can do that with the calculator. I don't care. It doesn't bother me which way you do that with the calculator on that. But you're just plugging that in and working it out. You've got to follow order of operations if you don't use the calculator. So when I square that, that's 4, then the negative. So that's -4 plus 8 plus 3, which would be -4 plus 8 is +4 plus 3 is 7. So 2, 7 is my vertex. 2, 7, or -2, 7, excuse me, is my vertex. So when I go to put that in my table, I'm going to put it where? In the middle. That's the key to being able to do this correctly, is knowing that that vertex needs to be in the middle. And I'm going to circle it, telling me that that's the vertex. When you get your assignment for today, there's part of it that you're going to do. That's what you're going to do, is you're going to circle the vertex in the table. Now, we need to go on the left side and the right side of that vertex. So what's to the left of -2? To the left of -2. -3 and -4. So that's the x values I'm going to use. To the right of -2 would be -1 and 0. Okay, so we're just going immediately to the left, immediately to the right. We're not trying to make it harder on ourselves. We definitely wouldn't pick fractions for x values here. That wouldn't make it easy on us. We're just trying to pick easy numbers. So the ones that are closest to it are ones we want to use. Okay. Now, how are we going to get the y values that go with those? Plug that into the equation. So I'm going to plug in. I'm going to start down here at 0. That looks like the easiest one to plug in. If I plug 0 in up here for x, I end up with 0 minus 0 plus 3. Cody? Yes, sir? Yeah, you were. You don't have a question, though? Okay. All right. All right. So if I plug a 0 in, that's going to give me +3. If I plug a -1 in, so it doesn't matter what order you plug these in at, you're just getting the ordered pairs there. I do want you to have them in order on the table, though, as far as numerical order. Don't put your vertex up top. Vertex goes in the middle, and left above it, right below it. Okay. So if I plug a -1 in, -1 squared is +1, and make it negative. Plus 4, so -1 plus 4 is 3. 3 plus 3 is 6. So the y value for -1 is 6. Let's go to the bigger numbers, the -3 and the 4. That should be a little bit more difficult to plug in, but maybe we can do it. So if I plug in -3, that'd be 9, make it negative, plus 12. 9 plus 12 is 3. 3 plus, or -9 plus 12 is 3. 3 plus 3 is 6. I plug in -4. That'd be 16 negative plus 16, 0, plus 3 is 3. What are we seeing here happening with our table? Look at the numbers. Yeah, the y values are the same. They're symmetric like the x values are, or like the graph is. They've got the same numbers on each side of the vertex. That doesn't have to always be the case, but it will be the case a lot. A lot. Okay? Now, next thing to do, draw your coordinate plane. So I wait until I get my table done before I draw my coordinate plane because I know my highest y value needs to be 7, and I don't need a whole lot in the negative direction of the y-axis. So when I draw my coordinate plane, I just make sure it's tall enough to get up to 7 and wide enough to get to -4. So that should be a decent coordinate plane to graph this one on. And I'll plot those points. -4, +3, -3, +6, 4, 5, 6, -2, 7, -1, +6, 0, 3. Now, what kind of value was the vertex? Was it a maximum or a minimum? Maximum. Does it look like a maximum in my graph? Yeah, it's at the top. The vertex is at the top. So that's a max. Okay. Axis of symmetry, it's just this dotted line going right down through the vertex. The axis of symmetry should always go through the vertex. If it doesn't, then you've either plotted the vertex wrong, or you've plotted your axis of symmetry wrong, or calculated something incorrectly. Okay, so here we have the graph of this parabola. It's got a maximum value. It's got a highest point. The highest y value is 7. It doesn't have a lowest y value because it keeps going forever in the down direction. So it goes toward negative infinity, what we call that. But it doesn't complicate things too much from what we did yesterday. Yesterday's stuff, definitely harder. You got to remember the formula. You got to change some signs. You got some positive and negative stuff happening. The hard part that I found in 10 years of teaching is folks making sign mistakes when you plug the numbers in. That's what's going to happen. It happens every year. Never changes. I don't know why, but it does. People just miss signs. It just takes taking your time, plugging the stuff in like it should be, and going from there. Okay. All right. When we come back from lunch, I've got a packet. I'll just pass them back or pass them out after lunch. And there's a few things that I want to go over with you once everybody's got one that we won't have time to talk about before we go to lunch. So when we come back from lunch, that's what we'll do. Okay.